be crazy. All right? So, station number 1, that's you've got your tray. You are going to have these two materials here. Here are 2 beakers for your use. Thank you. Station number 2, that's your group right there. Yeah.
I got it.
Station number 3, Quentin. Station 4 here, Craig. Now, station 6 is going to be a little bit different. Guys, listen up please. This station right here is going to be a little bit different. We have 3 different objects here, and you can choose 1 or more depending on your time. We have a cup of copper wire. We have pieces of copper tubing. And we have pieces of native copper. You can choose 1 or more, and there's a whole lot of supplies here for your use. Are there any questions so far? Yes?
No, I'm going to be quiet, wait.
Okay. All right. So here's your objective. In your student guide, and some of those beakers, guys, I've touched something, and maybe it's one of those beakers has something sticky on it, so if it does, would you please wash it off? In your student guide, it says density investigation, right here. We've talked about relative densities. We've talked about how it's the ratio of mass to volume. And we've talked about how manipulating the volume changes the density. So here is that formula for density for your use. Now we've got several different types of objects here. Now you know you can measure the you can measure the mass with the triple beam balance. Okay, everybody has triple beam balance, right? Yes? I hope. All right?
Yes.
Now, there's several different methods. There's 2 different methods that you can measure the volume of the object. What might those be? 2 methods we're coming up with for measuring the volume.
Displacement and
What do you mean displacement?
when you drop the object, will you take the measurement of the liquid, volume of liquid in milliliters first, and then you drop the object in there, and then you take the measurement of the volume of the liquid afterward, and then you subtract to get the volume of the object if it's irregular, and if it's a regular object, you can use the algorithm of length times width times height.
What if it's not? Do you always use length times width times height?
If it's measurable, if it's an irregular shaped object, you use displacement.
What if it's a sphere? Does length times width times height work for a sphere?
No, but I wouldn't be able to accurately
Okay.
measure the radius in order to do that because it would be, kind of guesstimate. So I would use displacement on that one.
So here's an issue with the language. We're using the words regular and irregular. Now in science, we just throw those words out, meaning regular means there's a formula to measure the volume. Irregular means there's not a formula to measure the volume. That's not true in math, right?
Right.
We discussed this yesterday, correct? So we're clear on our meaning,
So
right?
which word should you have used? Which word should I have used? An immeasurable
I am a
object?
scientist, so whenever I'm speaking,
But I do both.
yeah, so
which one would I use?
those are conversations we need to have about what is the proper terminology to use. So what should I have said, Dr. Browning?
I would prefer that you said it's not, you wouldn't call it a regular thing, you would call it a rectangular prism.
Oh, prism.
Call it the name of the shape,
Okay,
rather than just a regular shape.
If it's not a rectangular prism, but there's still a formula that I can calculate the volume,
Call it whatever the name of it is, like a cylinder. You could actually do the sphere because there are ways to measure the diameter and then cut it in half, find the radius. More complicated, but you can. But just call it the name of the object,
okay.
the mathematical name.
All right. So you have 6 stations. You have a whole page on which to create your very own data table to collect your measurements and your calculations. Yes, sir.
For some of these objects, when she said the displacement method, you are referring to the water displacement method, not alcohol or some other liquid?
Would it matter?
I think for classroom safety, water would be more appropriate.
Absolutely, yeah. Okay, y'all good? Okay, so we are, as always, running behind. So I want you to focus on getting this done and allow about 3 or 4 minutes at each station. And if we need to divide and conquer, that is okay. Yes,
The
quick.
question I was gonna ask was, when we get the water, do you want us to leave it, or can we dump it, or how do you want us to handle it?
There should be 2 beakers at each station, right? So if we need more beakers, why don't we gather water with one of these? So get the water in one of these beakers, and then just keep this as your water receptacle at each station. Toby?
Is there anybody that has never done the water displacement method of finding the volume of an object? Try not to splash your water out.
Yes, be gentle. All right, let's go. It is 10:59, it's roughly 11 o'clock. 3 times 6 is 18. We're gonna check back at 11:20.
Go ahead. So which station do you wanna call this one?
We're one.